I'm Charlotte Moser, co-director of the Vaccine Education Center at Children's Hospital of Philadelphia. And today on VEC Vaccine Notes, we're going to be talking about COVID-19. COVID-19 is a disease that most of us are tired of hearing about, and we definitely don't want to learn more about. However, the disease continues to cause millions of medical care visits, hundreds of thousands of hospitalizations, and tens of thousands of deaths each year. So for this reason, it's important for us to separate our emotions related to the pandemic from the realities of this disease today. As such, today we're going to go over information we know about the disease caused by SARS-CoV-2, the virus related to COVID-19. We're going to talk about the different vaccines that are available. We'll talk about some common questions we get, as well as the relative risks and benefits of COVID-19 disease and vaccination. SARS-CoV-2 is the virus that causes COVID-19. It's a bat coronavirus that emerged in China in late 2019. By early 2020, scientists had isolated that virus, determined its genetic code, and started working on a vaccine. All of this before the World Health Organization, or WHO, declared it a pandemic in March of 2020. COVID-19 vaccines became available in late 2020. The remarkable speed with which these vaccines became available likely saved millions of lives. But this speed also caused some people to have concerns about the safety of these vaccines. What's important to know is that the safety was not sacrificed for the speed. The reasons that we could do this, that this vaccine could be made so quickly, related to three factors. First, the tremendous financial resources provided by the U.S. government in the form of Operation Warp Speed. Second, the courage of tens of thousands of volunteers for the clinical trials. And third, alterations to the process that made it work more like several cars on a multi-lane highway rather than individual cars on the train tracks. So normally when a vaccine is made, the financial risk is taken by the company who's interested in making the vaccine. So what they do is they'll do the first steps of the process, like the first car and a train, and then they decide if they're going to move to stage 2, or in this case, train car 2. As the train is going down the tracks, there are decisions at each point before they move to the next car on the train. By the U.S. government removing the financial risks associated with vaccine development for COVID-19 vaccines, that enabled the companies to move more like multiple cars on a freeway, so that each car represents a step of the process and was in its own lane on this multi-lane freeway, moving forward simultaneously. As a result, no steps were skipped when we made these COVID-19 vaccines, but we were able to shorten the timeline significantly. And as mentioned, that likely saved millions of lives. One of the first things to talk about when we think about COVID-19 is the origins of the virus. And like the speed with which the vaccines were made, the origins of the virus have caused some points of contention. So let's start there. SARS-CoV-2, the virus that causes COVID-19, was identified in late 2019 in China. Two theories have emerged as to how that virus formed. The first posits that this bat coronavirus went into another animal and changed in a way that allowed it to infect humans. The second posits that the bat coronavirus was manipulated in a laboratory and then accidentally leaked, or was leaked in some way, to cause the pandemic. This latter version is known as the lab leak theory. Because of the limitations of the evidence that was able to be collected, we can't know for sure which version is accurate. However, the lion's share of the data point to the fact that the virus went into another animal and then spread to people at a seafood market in Wuhan, China. Because of the amount of evidence related to this theory, most scientists believe that this is the way that the original virus originated. However, it is everyone's prerogative to review all of the evidence and draw their own conclusions. One point is important here, though. The lab leak theory offers something that speaks to human nature. We like to be in control, and the lab leak theory offers an explanation that puts the blame on humans, which is more controllable than a virus emerging from animals where we had no control over that. So while that may be more satisfying, it is important to know, and this gets to another point, that new viruses emerge all the time. Virologists know this. When they study viruses, they see that. But what they know is that when new viruses emerge, most often they aren't able to infect humans and cause pandemics like we saw with COVID-19. In order to become a problem, a new virus must have three characteristics. It has to be able to infect people, it has to make them become ill, and it has to be able to spread from one person to another. SARS-CoV-2 met all three of those criteria, which is why it was able to become a pandemic. But most new viruses don't meet all those criteria and therefore don't become an issue. As we live, work, and play closer to animals, the chances for a new virus to emerge and become a global threat increase. On our webpage, we link to an article that explores the relationship between the actions of people and the emergence of potential new pathogens. So if you're interested in reading more, check out that article. So let's shift gears and talk about the symptoms of COVID-19. Many people will have COVID-19 and they won't experience any symptoms, or they'll have very mild cold-like symptoms. Some people can have more severe symptoms, and people can be sick for about a week. They can be hospitalized, they can be put in the intensive care unit, and they can die from this virus. So the severity really varies amongst different people. Symptoms can include fever, tiredness, muscle or joint pain, cough, sore throat, congestion, or headache. They can have a loss of taste or smell, develop pink eye, have gastrointestinal issues like nausea, vomiting, diarrhea, or loss of appetite. And they may have a rash or even discoloration of their fingers and toes. More severe symptoms can include difficulty breathing, confusion, chest pain, high fever, or blood clots. A few groups are at greater risk of having severe COVID. These include adults over 65 years of age, people who have health-related conditions including high blood pressure, chronic conditions of the lungs or heart, diabetes or obesity, people who are pregnant, and those with immune-compromising conditions. Now, there are three more severe complications that are worth discussing. They include myocarditis, multisystem inflammatory syndrome of children or adults, known as MIS-C or MIS-A, and long COVID. So let's talk about each of those briefly before we move on. When it comes to myocarditis, which is an inflammation of the heart muscle, we have heard of this associated with the COVID-19 vaccines, but some people aren't aware that it can also happen when they're infected with this virus. In fact, early in the pandemic, people were about 16 times more likely to develop myocarditis if they were infected with COVID-19 than if they weren't. Now, we think those rates of myocarditis during infection have decreased with the emergence of some of the newer variants, but we haven't been able to find data to support that. So we're hoping to see some data related to the rates of myocarditis now with the newer variants. When we talk about multisystem inflammatory syndrome of children or adults, again, MIS-C or MIS-A, there are three things to be aware of. First, the symptoms for this often appear weeks after a person has recovered from having COVID-19. Second, the symptoms are often similar to what you would experience during a COVID-19 infection, but because this virus can infect the cells of various organs, often there are multiple organs that are affected, and so the symptoms can be widespread. They can have symptoms related to problems with their lungs, heart, kidneys, a variety of different issues, which is why that syndrome is so concerning. And the third thing to know is that MIS-C and MIS-A were much more common during the earlier part of the pandemic with some of the older variants, and the rates of these syndromes have decreased over time with the emergence of new variants as well. Finally, I wanted to talk about what's come to be known as long COVID, which is the lingering of symptoms after a person has recovered from their COVID-19 infection. We don't understand this syndrome completely yet, but people have been experiencing months or even years of symptoms that linger after they've recovered. Sometimes these symptoms are things like brain fog or extreme tiredness, especially after physical or mental exertion. While anybody can experience long COVID, there are a few groups of people who are more susceptible to having these lingering symptoms. Those include people who are more severely ill, such as those who required hospitalization or needed intensive care treatment when they had COVID, those who developed MIS-C or MIS-A, people who have pre-existing conditions that increase their risk for severe COVID, and those who remain unvaccinated. SARS-CoV-2 is a respiratory virus, so it's spread through respiratory droplets, both large and small aerosolized droplets, which means those small droplets can hang in the air a little bit longer and make the virus a bit more contagious than if it was only contained in larger droplets. People can spread the virus, therefore, by not only coughing and sneezing, but also by talking and singing. When the virus infects us, it infects cells that line our nose, throat, lungs, and intestines. And during the pandemic, before we had vaccines or medications, we had to rely on public health measures like hand washing, social distancing, and covering our coughs to prevent the spread of this virus. However, mankind has never been able to get rid of a virus based on public health measures alone. So that makes vaccines important public health tools. Once vaccines were available, people could gain immunity more quickly and in a more controlled manner so that the virus would be transmitted less often and therefore would also not change as frequently. The fewer times a virus replicates, the less it's going to change. Now, we realized that some people didn't feel the COVID-19 vaccines worked because they could still get infected with the virus after they were vaccinated. But there are some things to understand about how our immune system works that provide important context for our expectations related to COVID-19 vaccines or other respiratory vaccines for that matter. First, we often get infected with respiratory viruses multiple times throughout our lifetime. That's because of the way our immune system works. Even after we've seen one of those viruses, it takes a few days for our immunologic memory to be activated and stop an infection. And during that period of days when our immune system is gearing up, that virus can still infect our cells and reproduce, and therefore may cause some mild symptoms. Once the immune system is up and running, the virus will be stopped and we won't get severely ill. Now, given the way that our immune systems work, vaccination is also not likely to completely prevent these kinds of infections because vaccination relies on immunologic memory. We give a vaccine in a known safe dose at a known time so that the first time a person sees this virus, they are able to develop immunity, but they don't have the risk of severe disease. So if we're making immunologic memory, and we know that immunologic memory takes a few days to ramp up after we've had another exposure to this virus, then you can see why even after vaccination, a person may still get mild symptoms. So that makes some people wonder what the benefits of vaccination are if it doesn't completely prevent infection. And for individuals, the benefits are twofold. First, as mentioned, vaccines offer us a way to know the day, the time, and the dose of exposure to this virus so that we know we won't have severe disease, be hospitalized, or die the first time we see the virus. We get an immune response, we develop immunologic memory, but we don't have the risk of severe disease. The second benefit is that we develop immunologic memory. So even though there is a chance that while the memory cells are being activated, we might have some viral replication and therefore mild symptoms, we still have immunologic memory that can benefit us in future encounters with the virus. So we're less likely to require hospitalization or get severely ill or die as compared to people who don't have immunity. Now, the other benefit that we've learned is that with COVID-19 in particular, people who've both been infected with the virus and been vaccinated are the people who have the best immunologic protection against this virus. So that offers another reason why getting vaccinated is beneficial. So let's switch gears and talk about the COVID-19 vaccines available in the United States. Currently, we have 3 mRNA-based vaccines and 1 recombinant protein-based vaccine. All of them target the spike protein on the virus that causes COVID-19. Now, the mRNA-based vaccines deliver a piece of mRNA so that our cells will produce the COVID-19 spike protein. mRNA is like a blueprint or a code. Every one of our cells in our bodies have mRNA because that's kind of the recipe for making proteins. So what scientists did was they took advantage of that recipe, and we now can deliver the recipe for the COVID-19 spike protein in this case, and our cells will make that protein. Now, the protein is made in specialized immune system cells that are near the site of the injection. And when the protein is made, our cells realize this isn't a protein that's supposed to be here, and they attack that protein, and that's how the immune response is generated. If you're interested in learning more about how COVID-19 vaccines, mRNA vaccines work, check our website because we do link to an animation that shows this process in more detail. The webpage also talks about the relative number of doses and the different mRNA vaccines that are available. So if you're interested, check that out as well. Now, one other note about the mRNA version vaccines is that the newest version is another vaccine by Moderna, and it doesn't deliver the mRNA for the whole spike protein. It only delivers the mRNA for 2 specific parts of the spike protein. And we talk about that a little bit on the website as well. The second type of COVID-19 vaccines available in the United States is a recombinant protein-based vaccine. In this case, the gene for the spike protein is put into insect cells in the lab. And as those cells reproduce in the lab, they also produce the spike protein, which is then purified to use as the vaccine. Now, this vaccine does contain an adjuvant, and an adjuvant is a molecule added to a vaccine so that the immune response is stronger. And the particular adjuvant that's used in this vaccine is similar to the one used in shingles vaccines. You can find more about that on our website. Now, there used to be adenovirus-based COVID-19 vaccines. Some other countries still use those vaccines, but we no longer use them in the United States because there were some pretty severe side effects related to those, and we had other options that were safer. So we're not going to talk about those adenovirus vaccines in today's discussion, but we do have information on our webpage if that's something of interest. When we talk about the side effects of COVID-19 vaccines, most are mild. Most occur within a day or 2 of vaccination and last for a day or 2. However, they can last, the side effects can occur within a week after vaccination, particularly after receipt of the mRNA vaccines. And most of the side effects are mild, things like injection site pain, tiredness, muscle aches, headache, or fever. Side effects from the COVID-19 vaccines tend to be more common after the second dose, and they tend to be more common in younger people rather than older people. Now, one more severe side effect has been identified, and that's myocarditis, which we mentioned earlier is an inflammation of the heart tissue. Infection with SARS-CoV-2 virus can itself cause myocarditis, but we also saw this after the vaccines, particularly early during the pandemic. And most often after the second dose, within 4 days of receiving that dose, and most often amongst younger males between their late teens and their late 30s. But it is important to know that anyone could develop myocarditis. So if anybody received a COVID-19 vaccine, you want to monitor for symptoms like shortness of breath or chest pains. Now, what's been interesting with myocarditis, if you recall earlier, we talked about the fact that we think rates have decreased with newer variants. And we've seen the same with the vaccines. And we have data that show that during the last 3 years, so that's the 22-23 COVID vaccines, the 23-24 COVID vaccines, and the most recent 2024-2025 COVID vaccines, the rates of myocarditis are no higher than background rates, meaning that when someone gets a COVID-19 vaccine, they're not more likely to experience myocarditis than if they were infected with either the virus that causes COVID-19 or another virus, because there are other viruses that can cause that symptom as well. So the good news is myocarditis is occurring less frequently with newer versions of the vaccine, but you'll still want to monitor for that. And although it's been more commonly associated with receipt of mRNA vaccines, there is a possibility that it could occur following receipt of the protein-based vaccines as well. So now let's talk about who should get a COVID-19 vaccine, because there may be some confusion. For people who never got a COVID-19 vaccine before, getting the vaccine now would be considered their primary series. The number of doses they would need depends on their age and which vaccine product they were receiving. So let's talk about people who were previously unvaccinated. There are two groups. First, there are the people who lived through the pandemic and never received a COVID-19 vaccine. For these people, they probably have some immunity to the virus that causes COVID-19. Now, we know that when people are both infected and vaccinated, they have the best immunity. So these individuals could still benefit from getting a vaccine because it could make their immune response to the virus more robust. However, chances are, because they have some immunity, if they were infected with the virus, they probably wouldn't get severely ill. Now, the second group are children who were born since 2020. We know that they're among the most vulnerable, in part because they haven't had as much exposure to this virus. We know that every year 3 to 4 million babies are born and they won't have been exposed to the virus at all, unless they get maternal antibodies, but we know those antibodies will wane. So as the antibodies from mom wane, the baby becomes more susceptible. And when we look at the data from the 2024-2025 COVID-19 season, what we see is that infants under 6 months of age were the most hospitalized group of children. With increasing age, the hospitalization rates went down. So the second most likely hospitalized group were infants between 6 and 23 months of age, and then children under 5, between 2 and 5, were the third most likely to be hospitalized. So what that tells us is that as these children develop immunity to the virus, they're less likely to have severe infection and be hospitalized. But it also means that it's really important for us to protect those youngest among us, because when this virus comes into our communities, they're the most susceptible, particularly new babies. Now, the other thing to remember about young children is that when we looked at children under 4 who were hospitalized, less than half of them had other underlying health conditions. So this virus can infect completely healthy children and cause them to be put in the hospital. Now, the other type of COVID-19 vaccination to consider is booster dosing. That is, giving doses to people who've previously been vaccinated against COVID-19. During the 2025-2026 COVID-19 vaccine season, it will be the first time that everybody isn't recommended to get a COVID-19 vaccine. And that's generally okay, because most people have existing immunity. Most people have existing immunity that's both from infection coupled with vaccination. So again, because of the way our immunologic memory works, if they get exposed, they may have a few days of mild illness. But generally speaking, we would expect that most people would not become severely ill. Now, this being said, there are groups who should consider getting booster doses and are recommended to do so. These are high-risk groups. That includes people 65 years of age and older, people with health conditions that increase their risk, such as high blood pressure, chronic conditions of the lungs or heart, diabetes or obesity, people who are pregnant, and those with immune-compromising conditions. Now, of note, people who are pregnant are not currently recommended to get this vaccine based on CDC recommendations, but many experts and healthcare providers, including the professional organizations, do recommend COVID-19 vaccine during pregnancy for 2 reasons. One, because the person is at increased risk for severe COVID-19 while pregnant. And second, because the antibodies they have against COVID-19 will passively transfer to the baby and offer some protection during that first 6 months of life. There are other people who may be interested in getting a booster dose, even if they aren't considered high risk, and they might be individuals who care for or live with high-risk individuals, or people who simply want to boost their immunologic memory against this virus to decrease the chance of having a COVID-19 infection sometime throughout the season. There are some people who should not get COVID-19 vaccines or who should be aware of specific considerations before getting COVID-19 vaccines. I'm not going to go through all of those details in today's discussion, but you may want to check our webpage if you have questions related to this, because we have everything spelled out there. The few notes that I would like to bring to attention while we're talking today. First, again, children less than 6 months of age cannot get this vaccine, which is why it's important for women to get that vaccine during pregnancy. But notably, if a pregnant person develops a fever from COVID-19 vaccine or from any other cause, they should consider taking acetaminophen, because a fever during pregnancy can negatively affect the developing baby. If you have questions about this, definitely talk with your doctor. The second point I would like to make is that if you just recently recovered from COVID-19, you may want to defer vaccination for about 3 months, because you'll have a better immune response if you wait to get vaccinated until at least 3 months after you've recovered. And likewise, if you did have COVID-19 recently and you were treated with convalescent plasma to help you recover from that infection, then if you need any live weakened viral vaccines like the measles vaccine or the chickenpox vaccine, there's a period of time you need to wait until you can get those vaccines, usually about 7 months. So again, check the website and talk with your doctor if you think this applies to you. And then the third point that I wanted to make is that there are a series of individuals who have special considerations related to if they had an allergic reaction to a previous dose of COVID-19 vaccine, if they are moderately or severely ill at the time they're thinking about vaccination, if they had MIS-C or MIS-A as a result of COVID-19, or if they develop myocarditis after receiving a dose of COVID vaccine previously. So if you're among any of the people in those groups, definitely check the webpage or talk to your healthcare provider to make sure that you understand the relative risks and benefits of vaccination for your specific situation. We're going to talk about some common questions we receive at the Vaccine Education Center. But first, I'm going to say that we get dozens of questions related to COVID-19 and the vaccine. And we have a dedicated page called covidvaccineanswers.org, where you can find all of those questions and answers. We periodically will review and update that information. And there's also a place where you can submit your own questions directly to us from that page, so that if you don't see a question that you have, we can address that. So let's turn our attention to some of the more common questions we receive. First, some people wonder if they've had COVID-19 in the past, should they get vaccinated? We talked about that at a few points during today's discussion. There is a benefit to getting the COVID-19 vaccine even after you've had a COVID-19 infection, because we've found that the immune response against this virus, the protection against this virus, is more robust in people who've both been infected and vaccinated. Sometimes people ask us also whether they should get the flu vaccine if they've got the COVID vaccine. And the answer to this is yes, because these two viruses are different viruses from different families. So when you get the vaccine for one, you're not going to get protection against the other. There was some scientists who were studying making a combined COVID-19 influenza combination vaccine, but none of those vaccines are available at this point. So to protect yourself this fall against both of those viruses, you would need to get the two separate vaccines. Some people have started reaching out to ask whether the cost of COVID-19 vaccines will be covered this year during the 2025-2026 season. And this is a difficult question to answer at this point. There's an organization known as AHIP, capital A, capital H, capital I, capital P, which is the professional organization for the insurance companies. In June of 2025, they put out a statement that said they would cover fall respiratory vaccines this season. You can check. We have a link to that on our website. However, it's important to know that individual insurance companies will be the ones making those decisions for their own companies. And so if you're not sure if the vaccine will be covered, you may want to reach out to your insurance company. And we would recommend asking about two charges, not only the cost of the vaccine, but also the cost for the administration fee. And you may also want to check with them if there's a specific place you have to get the vaccine in order for it to be covered. If you find that you don't have coverage, then you may want to reach out to your local health department to see if they're aware of any free or reduced cost COVID-19 vaccines that are available in your area. Or you may want to call different pharmacies in your area so you can do some comparative pricing research before you go to get your vaccine. We do have parents reach out to ask us about whether their children should get the COVID-19 vaccine. And it is the case that COVID-19 is mild for most children. However, there are a couple of considerations that we would usually share with parents who are asking us this question. First, if their child is just turning 6 months of age and becoming eligible for the vaccine, they could benefit from getting vaccinated against COVID-19. At this stage, antibodies that they received from their mom before birth are going to be waning, and so they will, and they likely won't have been exposed to the virus yet, so they will be susceptible to infections. And the vaccine can offer a way to provide a controlled first exposure rather than just taking your chances with their exposure in the community. Second, for children who are older, who've been vaccinated before, if they're healthy, they likely already have immunity. If they've been vaccinated and infected, they have among the best immunity that we have available, but they could potentially still benefit if you want to get them a booster, just to remind their immune system of this virus that's circulating. As our director, Dr. Raffet, likes to say, this is a low risk, low reward option. And then if your older child has never been vaccinated against COVID-19, as we've mentioned several times during our discussion today, the combination of previous infection coupled with vaccination provides people with the best protection against COVID-19. And so your older child could still benefit from being vaccinated, even if they were previously infected with this virus. Two other points are worth noting when you think about vaccination of your children. We talked about the fact that myocarditis is a more severe side effect that's been associated with these vaccines, but it's gone away essentially in more recent years. That's not to say people won't get myocarditis after being vaccinated, but the rates of myocarditis have leveled out, and it's similar to for people who aren't vaccinated as well as people who get the COVID-19 vaccine. And that's been the case for the last 3 years. So you would want to monitor your child for that side effect, but chances are they wouldn't have a problem with that. And the other point is that if you have a child who has any of the high-risk health conditions that we just talked about related to adults, so chronic conditions of the heart or lungs, obesity, any of the immune compromising conditions, they would definitely still be recommended to get a booster dose, at least one booster dose. And you would want to talk to your child's doctor to see what the recommendations are for their specific condition. So let's wrap up with a quick look at the relative risks and benefits related to COVID-19 disease and vaccination. Today, we talked about the fact that for most people, COVID-19 is fairly mild, but that we still see millions of people getting sick, hundreds of thousands of people being hospitalized, and tens of thousands of people dying from COVID-19 each year. We also know that while the rates have decreased, this infection can cause multi-system inflammatory syndrome in children and in adults, known as MIS-C or MIS-A. We aren't sure what the current rates of that are for the variants that are currently circulating. And we also know that people can get myocarditis with the infection. Again, the rates have decreased, but we don't know what the current rates are. and that they can also experience lingering symptoms known as long COVID, and we don't completely understand why those symptoms continue in certain people and not others. On the other hand, we know that the vaccines have generally mild side effects, with the one exception being myocarditis, but rates of myocarditis following vaccination have decreased to background rates, and that means that they're similar to people who didn't get vaccinated during the last 3 COVID-19 vaccine seasons. So although we would monitor for those, chances are that a person who gets the COVID-19 vaccine probably isn't going to experience myocarditis following vaccination. For that reason, when our team evaluated the relative risks and benefits for the COVID-19 vaccine, we felt that previously unvaccinated people who are eligible for vaccination could benefit from getting this vaccine, particularly the youngest among us, so children starting at 6 months of age. And for people who've been vaccinated before, some will benefit from booster dosing, particularly those who are at high risk for severe infection. We hope that after you've reviewed all of these materials, you'll feel the same way too. Thanks for listening today.